Alright, I had wanted to send a PDF to kind of show how to solve problems from Chapter 6 of Carey wherein you're asked to draw products for an alkene reaction. We've finished 7 now, and I want to illustrate how you can attack the regiochemistry of a reaction first and then consider stereochemistry if needed. So I've put 2 reactions up on the dry erase board here for our pentene, or butene, that we're going to consider here. So we have Br2 with water, which is a polar reaction with the butene, and HBr with peroxides, which is a radical reaction. So what we can do is, in a sense, just think about solving the problem here, just considering regiochemistry, and if we need to, move like into another layer, like on an onion, into the stereochemistry of a reaction. So let me illustrate that. Let's just go ahead and consider these 2 reactions. We know that this abides by the Markovnikov rule, so we would make some notes. This is a Markovnikov rule-driven reaction. We'd also say that there's no carbocation, some notes about the mechanism that will help us. This is again out of Chapter 6 for the Br2 with water. So it's okay, it abides by the Markovnikov rule. That is, when I make an attack on this bromine in the Br2, it goes to the carbon with the most hydrogens. And this water comes in and bonds to the carbon that's interior, since the bromine goes to the carbon that has the most hydrogens. So that's following the Markovnikov rule, knowing what our electrophilic site was, and we can draw the product just considering the regiochemistry that we would have. After the water loses a proton, we would have left just an OH, and we would have a halohydrin, a bromohydrin product. That's just defined regiochemically, where things are connected. Let's do the same thing over here, jumping back into a radical reaction, HBr with peroxides, remember, or light, or both. We have a radical reaction, and we tag it, and let's put it in parentheses, as anti-Markovnikov, meaning anti-Markovnikov, meaning that we don't have to, or that it goes opposite. It's not a polar reaction, but we're going to put the bromine on the outside and put what would have been the electrophilic site on the inside, the carbon that has the least hydrogens. So we can erase this hydrogen because we don't typically show just hydrogens, and this would be our product regiochemically. Now, we can do this. We can look at this and say, do I have chirality centers? That is the big question that leads us into Chapter 7. Do I have any chirality centers in this product? Chirality centers? I guess I'll put it in. Ask the question, do I have chirality centers? No. So if I say no, I don't have to do anything in the area of Chapter 7 because there is no stereochemistry. We can stop there. But here, let's see if we have chirality centers. Not here. There are 2 hydrogens there. But right here, we have a chirality center. So now what you can do is say, if chirality center, I'm going to have to go into Chapter 7 and know where this sits on the wedge or the dash, or at both. Let's go back to our original reagent. It is achiral. The reagents here are achiral. There's a big rule that leads us into stereochemistry. A plus A must give an achiral molecule or a racemic mixture. So we can use that rule to say, okay, if I made this regiochemically, I know that for sure. I have a chiral molecule, the reagents were achiral, I must go into Chapter 7, or consider stereochemistry, and make a racemic mixture. So I'm going to have both the wedge and the dash for that OH. So I have both now representing the product for this reaction all the way down at the bottom here. The halohydrin with stereochemistry noted, and I must have a 50-50 mixture of these 2. That's how we can solve these problems, getting the regiochemistry first, and then asking the question, is it chiral? And if it is, then we can start using this rule, along with any notes we have about the reaction. We know this is an anti-addition, but we're not generating a chirality center here, so we don't have to consider the bromine on the wedge or the dash. So we can just simply go ahead and put the OH on the wedge and the dash. Right, that's again a very good way of attacking a problem that has both regiochemical and stereochemical concerns. Attack one first, and then attack the stereochemistry second. Thanks.